Yep, so I'm Jason Weston. Yeah, this is work at Facebook AI Research Group, which is a pretty new group, more or less started just at the end of last year. And yeah, so this is sort of one of our first works in NLP. So we're trying to use hashtags to learn like good feature representations for text. So, I mean, in general, like Facebook would like to be able to understand like text, right? In particular, all these posts that people are writing on Facebook. So, you know, one way to try and understand all these billions of posts is to do more like symbolic things, like try to do entity linking and parsing and, you know, all the plethora of tools we have in the NLP community. And sort of another way, which is also quite well explored these days, is instead to just try and find some latent features, right? So like an embedding space, which describes your text. So it's not very interpretable, but hopefully those features, you know, somehow capture the semantics of the text, and then you can use those in various other tasks. As you know, as you see at this conference, you know, for example, lots of people using word-to-vec latent features for various tasks. So in this work, we try to learn those latent features not via an unsupervised method like word-to-vec, which just works on text, but using hashtags as a kind of supervised way of learning those embeddings. So we take lots and lots of posts which have hashtags, so you know, lots of users are adding these hashtags to their posts, and then try to learn these latent features, the embeddings of a post that predict well the hashtags. So we effectively have this really large, like supervised training set where we, you know, the annotation cost was relatively minimal for us, because you know people are adding those hashtags. And the good thing about those hashtags is that they kind of give you the intent of like the author, both in you know sort of what they want their reader to you know, take out of it, and you know what's their intent as the author. So and it covers kind of like various different NLP tasks, and it can. You could see these hashtags as like weak labels for those tasks. For example, disambiguation, like chips, hashtag futurism versus chips, hashtag junk food, like identification of named entities, like San Francisco 49ers, sentiment detection, like people put hashtag dislike or hashtag yummy or something, you know, and topic annotation. So, you know, there's lots and lots of these hashtags, so it's not like a small set of labels. You need to have a method that deals with a ton of labels, but it covers like a lot of diverse different kinds of interest in terms of the sort of semantic meaning of the text. So, yeah, that's what we want to explore. Can we learn these embeddings and then, you know, create these good features? So we tried two different ways of learning the embeddings. One is a linear embedding approach, which is basically called Wasabi. That's an existing method that's been used for other supervised embedding tasks. We just applied it to hashtag prediction. And we try a more complicated method, a convolutional neural networks, which basically has, you know, word embeddings and then a series of nonlinearities before it gets to the final latent representation of the whole post. And we compare these. And both of those methods, so the linear one and the more complex one, are trained for this supervised task of predicting the hashtags. And particularly, we treat it as a ranking task. So we try and get the true hashtags for, you know, a given post in our training set. We get those hashtags to be ranked highly out of the list of all possible hashtags that we've seen. So we sort of solve that as a ranking task. And then after we've learnt those embeddings, which, sort of implicitly as part of the model for predicting hashtags, we try and measure whether we've actually captured some semantics with these representations by transferring them to a different task. So we take the task of personalized document recommendation, which is basically, one of the important tasks of Facebook, like what documents, which posts should we put high up in the feed, like to show a user. We try to see if these are good features for that task. And it turns out, they work better than, say, something more unsupervised, like Word2Vec. That's basically the take-home message at the end. So this embedding paradigm, which probably many of you know, as there's lots of things at the conference like this, it's basically that each word we're going to learn a vector for it. It's like a d-dimensional vector. So, like Word2Vec does that as well. We're also going to have a d-dimensional vector for every hashtag. So in our experiments, this is kind of the order of like a dictionary of 1 million words and 100,000 possible hashtags. And then after we've got these representations of each word, they're going to go through some function, some learnt function to produce the d-dimensional embedding also of the whole text of the whole post, which is typically, sort of 1, 2, or a few sentences, that kind of size, So there's these two approaches, the linear one, which basically it's very simple. It just takes all the d-dimensional embeddings of each word and just takes the average. So, I mean, if you look at this embedding matrix that we're going to learn, it looks sort of like this. We have all these words in our dictionary plus hashtags. So the hash TBT there, like Throwback Thursday, is like a popular hashtag. So all of these have a d-dimensional embedding. So those like colored squares represent real values. So the linear embedding model that we use, Wasabi, takes, like for some posts, so here it's just a 4-word post, crazy commute this AM. So you take those d-dimensional vectors and you just average them, so you get just this one d-dimensional vector that represents this whole post. And now we're going to try and find the hashtags that are, indicative of that post. And the way we do that is we take every possible hashtag. So here's one example, the hash TBT. We take its d-dimensional vector, which we're also going to learn, and then the score between the post and the hashtag is the dot product between the two. Okay, so then the thing is that this is trained supervised. Basically, for every training example with the text and the hashtag, you're going to kind of, like, if you think of this as a very simple neural network, you're going to backprop through like both sides to update the d-dimensional vectors for the words and the d-dimensional vectors for the hashtags, such that the true hashtags are ranked highly. So that's the simple one. And then there's a more complicated model, which is the convolutional neural network. And so that looks more like this. So the same post, crazy commute this AM, rather than just taking the average of all those words, the first thing you do is this sliding window, which you'll need to, you learn a matrix which applies a sliding window. Here it's of size 3 words. And so you put these special padding things either side. In this case, because it's a window of 3, it's just 1 padding. If it was a window of 5, there'd be 2 paddings or something like that. So there's a matrix you learn that applies that convolution. And then now you have a representation of kind of each window in the text, and then you still need to do some further layers of processing to finally get to the d-dimensional vector that represents the whole post. In this case, we use a max pooling, basically, so then over those windows, so that turns it then from number of windows back down by D, the embedding dimension D, back down to D, and if it was D, sorry. But you could actually have a hidden dimension size n in general there. Actually, you could go, say, from a d-dimensional vector for each word up to 1,000 dimensions and then back down to d or something like this. That's actually what we try in our experiments. So that's kind of the cartoon version of the CNN. The actual one we use is like that. It looks a bit more complicated. So like I was saying, yeah, you could have 1,000 hidden units. You have a sliding window size 5. The Ds we try are like 64-dimensional, 128-dimensional, 256-dimensional embedding spaces, this kind of size. And so you've got the post words coming through on this side, going through the convolution and the max, and then a final linear layer to get down to D dimensions here. And on the other side, you have the hashtag, one of the hashtags you're considering that you just get the D-dimensional vector of that and do the dot product, get the score. So that's kind of the score for one post tag pair. And then you have to apply that for every tag to rank all the tags. So let's see, did I miss anything? Nope. So yeah, so all that's left to do is basically train the parameters of these models. So to do that, we use stochastic gradient descent with this ranking loss that I'm talking about. So basically, we use the classic margin ranking loss that's written here. So, so this is this score between a post and a positive tag. We want that to be higher than the score of a post and some negative tag. So you basically pick a random training example during your SDG steps. You then pick one of the positive hashtags for that post, if there's multiple. You search for a negative out of your whole dictionary of hashtags such that it's higher than the positive with this function f. And then you make a backprop, if you like a gradient step such that it's not higher, right? Such that you're pushing the f post tag plus to be larger and f post tag minus to be smaller. And you can apply this training algorithm to both the linear wasabi model and the CNN. So that's what we do. So we tried 2 different data sets. They're both, of the same kind of thing, except one's basically like written by kind of people, and there's 200 million such hashtagged posts that we collected, and the other one's more like by public entities, like businesses, celebrities, brands, or products. So we call that the pages data set. It's a little bit smaller, and then we apply these models. We compare them to a few baselines. So the important one is Word2Vec, which is basically trained on the same data, but it doesn't use the sort of hashtag supervision directly. We leave the hashtags in the post, so it sees them, but it's also trying to predict all of the words. Like, it takes a window around each word and tries to predict, depending on, like this. So it doesn't sort of focus on this supervised task. But the other 2 baselines are basically just sort of sanity check baselines. One is just a ranking by frequency of tags, and the other one is like take the original post and put hashtag in front of each word, because often people sometimes, repeat one of the words in the post and put a hashtag next to it. So a couple of things about statistics of these 2 data sets. They're kind of like quite different distributions. There's like in the people data set, so here's the top 4 tags are like more sort of personal things like love and happy, and whereas in the pages data set, which is more like the business entities, it more looks like ad sort of words like beauty, luxury, cars. So they're quite different looking that way, and there's also this difference in terms of like the top 100 tags account for 34% of page tags, but only 13% of people tags. The upshot of that being that when we look at the metrics, it's basically the pages data set is much easier. So the metrics look higher. So here's the people data set results. So here's these baselines I was talking about. The sort of sanity check ones are actually not, they're not that different to Word2Vec in the end. I mean, they're just a little bit worse in precision at 1. So we have 2 different embedding dimensionalities here that we trained Word2Vec on. And here is like the linear version of our training on hashtags, so aka Wasabi, and the convolutional neural network version, which ended up a little bit better, basically, than the linear one. Wouldn't say it's massive differences, a little bit. On the page data set, the gap is a little bit bigger between linear and CNN. And the gap to Word2Vec is like pretty huge, I would say. So you could argue, by the way, that you could take the Word2Vec representations and add a supervised classifier on top. This is what like Thomas Mikolov, the author of Word2Vec, would say. But that wouldn't actually affect the word embeddings, which we're going to do a task transfer to this document recommendation task. So it wouldn't really tell you about the quality of the embeddings in terms of how they're capturing the semantics. So here's some example predictions on some posts that I basically made up. They're not from actual users. Are they too small to read? So it's like crazy commute this AM, was lucky to even get into work, and then these are the top hashtags we predict with the convolutional neural network model. It's like hashtag NYC, hashtag snow, hashtag pure Michigan, snow day, snowstorm. It happened like when we collected this data set, it was back in February, it was a snowstorm right then, so these were like all the things that happened at that time. So there's a post about marriage equality, and then you get all these hashtag equal rights, LGBT kind of tags. Kevin Spacey predicts like House of Cards that he plays in, and these sort of swoon, hubba hubba hashtags, because it's like, what a super hottie. So it kind of gets these two different meanings. Yeah, I went running today, and it's like hashtag running, hashtag ouch, pain, no pain, no gain, because I put part of the post is my feet hurt so much. So again, it's kind of getting both of those things. Mesut Ozil is mentioned, and it's sort of predicting all these hashtags about Arsenal. It's the team he plays for, like, come on you Gunners, is hashtag COYG, and so on. So you can see these sort of sentiment things, like the restaurant was too expensive and the service was slow, and you get these hashtag rip-off, hashtag first world problems kind of stuff too. There's a post, he has the longest whiskers, OMG, so sweet, and it sees this is probably about a cat, so there's all these hashtag kitty, meow, and so on. So yeah, lots of different, diversity of text it can capture. So, we see if these are good features for something else. So we tried the document recommendation task. So we took 34,000 users, and their like histories are when they like posts. And so we take like n posts that they've liked, well, n+1 posts that they've liked, and we hide the n+1th to the representation we're going to build of the user. We represent the user with these n posts, with these latent representations of the post, and then we score the n+1 post by the dot product between the previous n post and the n+1 post. And we're going to basically rank a whole bunch of posts and see where the true one appears. So it should appear at the top, basically, or near the top, because they liked it. So that we basically take those models we trained, those latent features, and just apply them directly at that task. And these are the results. Yeah, so again, we see a bit of a gap from Word2Vec and these tag-space models. They're a little bit better. Well, actually, I mean, recall at 50, you've got like 4% for Word2Vec and sort of like almost 10.7% for the convolutional neural net. Actually, bag of words is at 8%, so I mean, it's worse than that. You can actually add bag of words scoring to this latent features as well, and you actually get a little bit from that combination. That's the last set of rows. Yeah, so basically that's it. We trained with hashtags, learn these latent representations, and it seems like, you know, it's getting something from that, and you learn some features which could be used in other tasks, for example, in document recommendation. And so, yeah, the supervision seems to matter because, you know, that looks better than Word2Vec, and the word order and sort of non-linearity of the model can help a little bit too. So that's when the CNN is better than the linear model. So yeah, like in those results here in the document recommendation, we see a bit of a gap between those. And that's it. Yeah.
Some questions?
Thank you for the talk. 1%, precision at 1. It looks frightening. I mean, is this useful or?
Well, no, but the thing is, so we only have like one positive document that we're trying to rank out of a huge set. So the evaluation isn't actually of the quality of the one that's top ranked. It may actually be relevant to you. Okay. You see what I mean? So we're only getting credit if we get that one at the top. So it's not actually an evaluation of the quality to a user. It's just a way of measuring difference between methods.
I mean, did you have some sort of like manual evaluation where it suggested hashtags, even though it was not the hashtag that the user initially wrote, that somebody came afterwards and said, yeah, this looks like something reasonable?
No, but the hashtags, it looks much better. Like, for example, on this data set, right, you've got like 37%.
Okay.
And that's with 100,000 hashtags. So, and again, just because it says it's wrong there, it doesn't mean that hashtag isn't relevant. It just wasn't actually in the post. So there might be like a synonym, for example, that you ranked higher. So we're not actually giving credit for those. So I think, and then as you saw in the examples, right, like they're not bad, right? So I think
they look better than 1%.
Yeah. So I don't think that metric's kind of like a real lower bound kind of thing.
Now, concerning this example, the first one, I mean, it seems, you know, if you use other meta information that Twitter is actually providing you, like the person's location or the person's, you know, history of usage of hashtag usages.
Absolutely.
I mean, it would make perfect sense. I mean, from New York City to
then you could do
to Michigan.
Better,
I mean, it's a long distance.
If you used some metadata, you could about the user, like you knew about that particular user, you could definitely do better. So our goal is to try and learn these, you know, feature representations from content from text content. So then we can transfer that to other text. If you want to sort of optimize for a specific task, like where you have lots of other data, then you should use that.
Okay.
And of course, you know, Facebook would use that. But here we're just, you know, assessing the quality of this sort of text model.
Thank you.
Hi. So people often use misspellings of words on Facebook. So I was wondering if you do any pre-processing, and what's your vocabulary size?
1 million words is our vocabulary size. So we're not doing any pre-processing, but that's going to capture some sort of frequent misspellings, basically. But if they're sort of a relatively rare misspelling, we just, in this experiments, it will just disappear. It won't be in the representation. So you can do things like other groups have done, like just model like subword things like trigram of letters and things like that as part of your embedding space. But we didn't do that here.
So even if a word appears a single time, it would still be in your vocabulary?
Well, no, because we took the top million. So.
Oh, I see.
So there are many more words than a million.
But then if in a post, if there is one word in the middle that's not in your vocabulary, so you replace it by some unknown word, or do you just ignore it?
So in the linear model, it wouldn't make basically any difference. If you, I mean, you could sort of put you can have this unknown word. That's basically the way of dealing with it. You make another embedding called unknown, and you know, sort of in the CNN that would matter more because it's actually using the word order.
Thanks.
Hi. some of the examples I'm seeing here, they are actually quite fascinating to me. I'm just wondering that all the examples we are seeing on the left, they seem like very subjective. So the person is demonstrating an opinion, but I'm guessing there would be other cases where they would be just objective descriptions. So I was wondering if the dataset had any bias towards opinionated text or subjective text in any way.
Well, I mean, it's just biased to what people actually write. I mean, this isn't really probably a good selection of things that actually covers the distribution of what people write. In any way, it's too small a set. But I mean, you can imagine what people write on Facebook, right? It's often very, very subjective. I mean, lots of posts are about your daily life and things like that. People, also write about, more like current events and things like that, but then they might put their opinion as well. I don't know. But yeah, probably the other data set, the pages data set, might contain more things like you said you're looking for. But yeah.
Most posts are subjective or opinionated at least.
Okay, if there are no more questions, then we'll thank the speaker again. Actually, we thank all the speakers, and thanks to you for attending the session. Thanks.